So in one of the early videos, I gave you this simple example where the bank interest is 100% and then you put $1 in there. If you compound it every second, it will give you what's very, very close to E. So if you decided to compound it every nanosecond, or as this thing here heads towards infinity, then it will eventually lead you to the number E. So in this video, we're going to look at a similar example, but instead of a simple 100%, we are going to look at a weird interest rate, which is 7%. And instead of $1, we would put in a random $400. But in this example, even though it's a weird interest rate, it will still lead you to the number E. So let me just illustrate it. So at the start of the year, remember we're putting in there for 1 year. In a future video, we will consider, I don't know, 6 years. But let's just look at 1 year for the time being. So right at the start of the year, you put 400 in here, so your 100% is $400. And then if you decided to compound it over n number of times, then well, at the start, you have $400, and then you would need to get this times this. So your amount in the bank. So if you want to compound it every month, then this n here will be 12. So you get your interest rate, and then you divide by 12. But we want to compound it n number of times. So it will be this times this. So your new amount would be 400 times this thing here, which will be 1 plus 0.07 over n, close it off. And then so this is your current amount in the bank. So this then becomes your new 100% on your next iteration. So your new 100% is given by this thing here. So this thing here is this thing here. And then when you compound it again, it would be this times this thing here. So that will then give you this thing here. So if you do it, let's imagine we're going to compound it every month. So this will be 12. So what that means is we cut up into 12 equal pieces here, and then this would represent our second month. But we want to do it n number of times. So it's going to be dot 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 dot, and then dot 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 dot. So this is after us compounding it n number of times. So it would be n minus 1, and then we would times this exact same thing again. That will then give us this thing here. So this thing here represents our whole amount after we compounded n number of times. Later on we can take the limit as n tends to infinity, meaning we continuously compound it. So our final amount would be given by this thing here, and then we take the limit as n tends to infinity, meaning we're going to compound it many times continuously. We're going to compound it continuously. So our total amount in the bank is given by this thing here. So remember remember when you take the limit of a constant, you're able, this is a constant, it doesn't change, you're able to take it out here. So that will then give us this block multiplying with this block here. But the thing is, we know that the number E is given by 1 over the bubble, but here we've got a weird amount. It's not 1, a weird amount. So we would use this trick that we always use when we evaluate limits. We want to turn this into something similar to this, where this thing here is the number 1. So this is a trick that we normally use. So let this thing here be 1 over x. So 1 over x is this thing here, and then times both sides by n. So that will then give us this, and then times both sides by x. So that will then give us this. So we are basically trying to transform this into this. Hang on, into this, because the nice thing is that this is 1 over x. So let me start again here. We are currently here at the moment. By using this trick here, allow this to be the same as this. So so now notice that this thing here is exactly the same as this thing here. So we can put this into here. That will then give us this thing here. And then what is n? Well, n is this thing here. N is this thing here. So we can put this thing here into the n. That will then give us this thing here. But then we got to think about what happens to x, because we are changing the n into x. So what is happening to x as n heads towards infinity? So wait there. So looking at this, we want to know, because for us to translate this, we are moving from n to x. So what is happening to x as n heads towards infinity? Well, going back to here, let's make we want to know what happens to x. So let's make x the subject. Let's divide both sides by this. So divide both sides by 0.07. Now that will then give us x is equal to this thing here. So up here, as n heads towards infinity, what's happening to x as this n gets bigger and bigger and bigger? Well, as this thing gets bigger and bigger and bigger, even though you're dividing by 0.07, this bubble here will also get bigger and bigger. So when you translate a limit from n to x, it turns out that as x heads towards infinity, as n heads towards infinity, x, in our example here, x also heads towards infinity. It's just a coincidence that by making this substitution, as n gets bigger and bigger, it so happens that x also gets bigger and bigger. With certain substitutions, as n gets bigger and bigger, x might get smaller and smaller. We don't know. But in this case, x gets bigger and bigger. So we can now translate this. Limit into this limit. They're exactly the same, but it's just that, hang on, as x tends to infinity, they're exactly the same. It's just that we have 1 over x rather than a weird amount here. So this thing becomes this thing here. Okay, so now hang on. So we are currently here. So now let me think. X to the power of a to the power of b, that's the same as x to the power of a b. So here we've got one thing multiplying another thing. Here we've got one thing multiplying another thing. So I can drag this outside here. So 0.07 becomes an index within, well, it's a power of a power. So I'm just using this thing here. All right. So from here, that will then take us to here. And now let me think. Now this thing here, we hang on. We are currently here. So now I can drag this bracket here out here like this. What I'm trying to say here is that evaluate this whole thing here. Once you've got this whole thing here, you can power it by 0.07. So let me elaborate on this. So what I'm saying here is that you can drag this squared bracket out here, just like this thing here. So what I'm saying is you can evaluate what's in here first. Once you've got that limit, then power it. So let me just explain this step here, from here to here. So let's say you've got a function f of x, and let's say up here you've got f of x, and then you power it by this weird number. So yeah, you're powering it by this weird number here. So rather than let's look at when it's a. So f of a is right here, and then so this is f of a, when you're at f of a, if you power it by 0.07, you would jump to here. Let's look at b. So b is here. So this here is f of b. So this here is f of b. When you power it by 0.07, you will jump to here. So let's go back to a here. So this is a. So you, rather than you trying to find the limit of this thing here, you finding the limit, rather than you trying to find the limit of f of x to the power of 0.07, which is what we're trying to do here. We are trying to find the limit of this thing to the power of this thing here. Rather than you trying to find the limit of this, what I'm saying is find the limit of f of x. Find the limit of f of x. So find the limit of f of x. So find the limit of f of x. Once you've got this limit here, then you can just power it by 0.07. It would jump to the same place. So that's why you're able to. Well, here you're trying to find the limit of this whole thing here. What I'm saying is that find the limit of this thing first. So that's us finding the limit of f of x. Once you've got the limit of f of x, then power it. It will take you to the same place. So hang on. So rather than you trying to find the limit of this complicated thing here, what I'm saying is find the limit of this thing first. Once you've got that limit, then power it by 0.07. And then notice that this thing here, is the number e, because 1 over x. Well, I'm expecting you to know this. This thing here is the number e. So 0.07 is here, and this is your initial amount here. So the amount in your bank account is given by this. If you compound it continuously, it will give you this amount here. Don't forget, this is just a constant. Is a number e to the power of this weird thing here, and then times 400. It will give you an amount that represents how much money you have in the bank if you compound it continuously. Okay.